Welcome to the front lines of defense. This is Indian Defense Affairs.
In modern aerial warfare, stealth technology and high-power electronic jammers often blind conventional radar systems. India's Defense Research and Development Organization, DRDO, is preparing to challenge this dynamic with its indigenous microwave photonic radar. Developed by the Electronics and Radar Development Establishment, LRDE, in Bengaluru, this system is progressing from successful ground acceptance tests toward airborne trials on combat platforms. The technology, replacing electronic circuits with light. Traditional radars generate and process radio frequency, RF, signals using purely electronic components, which introduces signal noise and bandwidth limitations. DRDO's photonic radar bridges the worlds of photonics and microwave engineering by using laser diodes, optical modulators, and photonic integrated circuits, PICs, to generate and analyze RF signals. Because light waves provide picosecond-level timing precision, the system produces ultra-clean, wideband microwave waveforms with exceptionally low noise floors. Why photonic radar changes air combat? The shift to light-based signal processing delivers three tactical advantages over conventional active electronically scanned array (ASA) radars. Centimeter-scale resolution. The radar achieves spatial resolutions down to 1.3 centimeters. Instead of seeing a flying target as a single pixel or dot, pilot displays receive detailed, 3D target reconstructions capable of distinguishing between a bird, a small drone, or a cruise missile. Jamming immunity. RF jammers operate by overwhelming an incoming radar's electronic receiver circuits. Because photonic signal conversion occurs in the optical domain before digital processing, the system is inherently resilient against conventional electronic countermeasures, ECM, stealth target detection. Radar-absorbent materials and angled airframes on fifth-generation stealth fighters are tailored to scatter specific electronic RF frequencies. The ultra-wideband emission and clean signal fidelity of photonic radar increase target sensitivity, helping uncover low observable targets. Operational roadmap and multi-platform deployment. DRDO has structured a phased testing regimen for the system. By deploying photonic radar chips onto airborne fighters, surveillance aircraft, and frontline air defense networks, DRDO aims to give the Indian Armed Forces a definitive edge in high-intensity electronic warfare environments. The operational roadmap. Following site acceptance tests and anechoic chamber trials, airborne flight testing will evaluate the radar's real-time AI signal processing under dynamic flight conditions. Once operational, the technology is slated to equip India's Su-30 MKI fleet upgrades, Tejas Mk-1A Mk-2 variants, and the upcoming AMCA 5th generation stealth fighter.
This is Indian Defense Affairs.